So let us learn Cauchy's residue theorem. Let f of z be a function which is analytic inside and on a closed curve C except for a finite number of singular points z1, z2, z3, etc. zn inside C. Then integral f of z dz is equal to 2 pi I into sum of residues. You see f of z a function which is analytic. Suppose you have a closed curve. Inside closed curve is C, okay, and inside and on the closed curve. So inside and on the closed curve, on the closed curve C, on this curve C, except for finite number of singular points. So for some singular points, you may have some points here z1, z2, z3, like that. Okay, for some points. Except for finite number of singular points z1, z2, zn, etc. inside C, integral over C f of z dz is equal to 2 pi I into sum of residues. So here the function is analytic everywhere except at certain points. Okay, that points are called as singular points. Already we have learned singular point means at those points the function is not analytic. The function is not analytic at those points. So here f of z is analytic everywhere except at certain points z1 to zn, they are called as singular points. Then we say integral over the curve C. Okay, here you should write C. Integral over C f of z dz equal to 2 pi I. This bracket is into. Okay, we have to multiply 2 pi I into sum of residues. We'll do some problems. Evaluate integral over C z by z plus 1 into z plus 1. Sorry, z minus 1 into z plus 1 dz, where C is modulus of z equal to 2. So now to evaluate this, we'll use this Cauchy residue theorem. That f of z is equal to z by z minus 1 into z plus 1. Okay, and here we know to find the poles, right? Poles means the points where the function is not analytic. So equating the denominator to 0, already we have did this. Equating denominator to 0, we get z equal to 1 and z equal to minus 1. Okay, from this first term z minus 1 equal to 0, z equal to 1. Z plus 1 equal to 0, z is equal to minus 1. And now what we are going to do is, after finding the poles, we have to find the residue. So both the poles are symbol poles. Okay, they are symbol poles inside the curve C. So why do we say it lies inside the curve C? The curve, you see, the curve is mod z is equal to 2. Curve is mod z is equal to 2, and mod z minus a is equal to r is circle where a is center and r is radius. So comparing with this, we can identify this as a circle. Okay, mod z minus, let me take 0 is equal to 2. This is 2. Okay, so now center, a is the center is 0 and radius is 2. Therefore, so if you draw a circle, also anyway it will lie with the center 0 and radius 2. If you draw a circle, this point will be 2 because radius is 2. This point will be minus 2 because radius is 2. Okay, radius is 2. So now what about 1 and minus 1? So at this point we can plot 1 and at this point we can plot minus 1. So both 1 and minus 1 lies inside the curve C. Okay, this is our circle C with a radius 2 and with a radius, so this point is 2 and this point is minus 2. 1 and minus 1 lies inside the curve C. Okay, so also or we can verify modulus of z is equal to 2. When z is 1, mod 1 is equal to 1, which is less than 2. Okay, less than radius. Less than radius means lies inside. Okay, less than radius means lies inside. If you take minus 1, mod minus 1 is equal to modulus of minus 1, we take the positive value, absolute value it is 1. Again it is less than the radius. Radius is 2, right? Less than the radius. Therefore again it lies inside. Again it lies inside the curve C. So after identifying that these points lies inside, okay, it lies inside, and also they are simple poles because there is no repetition. They are simple poles. Now let us find the residue. Okay, finding the residue, we did a lot of problems. Residue f of z at the point A is limit z tends to A, z minus A f of z. So now the points are 1 and minus 1. At the point 1, A is equal to 1. Residue at the point 1, limit, replace A by 1. Limit z tending to 1, z minus 1. F of z is our question. Z by z minus 1 into z plus 1 is our f of z. That is our question. Substitute it here. Now z minus 1 is eliminated. We get 2 by z plus 1. When z is 1, we get 2 by, here z is 1. So 1 plus 1. We get, okay, this is z by. So here we get z is 1. So we get 1 by, okay, 1 by 1 plus 1. So 1 by 2. Z plus 1. 1 by 2 is the 1 by 2 is the answer here. So now we'll continue. Similarly, you can find residue at the point minus 1. So replace z a by minus 1. Z tends to minus 1. Z minus a, right? Z minus a means z minus of minus 1. Z plus 1. Then f of z is our question. Z by z minus 1 into z plus 1. So here z plus 1 will be eliminated. Okay, z plus 1 will be eliminated. Z by z minus 1. Z is minus 1. So minus 1 by minus 1 minus 1. Minus 1 by minus 2. That is 1 by 2. So after finding the residue, by Cauchy residue theorem, what is the solution? Integral over C f of z dz is 2 pi I into sum of residues. So our answer is 2 pi into sum of residues. What are the residues here? It is 1 by 2 and 1 by 2. So 1 by 2 plus 1 by 2. 1 by 2 plus half is 1. So our answer is 2 pi I. Next question, you can try this similar to the previous question. Integral C 3z plus 1 by z minus 2 into z plus 4 dz, where C is mod z equal to 3. Find out the poles by equating the denominator to 0. So here you get, okay, this is integral over C, equating the denominator to 0, z is equal to 2, z is equal to minus 4. So both 2 and minus 4 are simple poles because not repeated. Okay, 2 and minus 4 are simple poles, not repeated. Now whether it lies inside, you can take this is a circle, mod z is equal to 3. So when z is 2, mod 2 is 2, which is less than 3. 3 is the radius. Less than radius means lies inside. Again take modulus of this, mod minus 4, positive, you have to take the positive, which is greater than this radius. When it is greater than radius, it lies outside. Okay, here it lies inside. So 2 lies inside, minus 4 lies outside. Okay, so also you can verify like this, mod z equal to 3 is a circle with center and radius, with center 0 and radius 3. Therefore this point is 3, this point is minus 3. When you take 2 lies inside. When you take z equal to minus 4 lies outside. So you can follow any method. Either you draw the graph and you try to understand, or it is simple. Simple thing you can do is just you substitute it here. You can substitute this 2 and minus 4 here. If it is less than 3, lies inside. Therefore it lies inside. The other value lies outside. Okay. Also both 2 and minus 4 are simple points. Minus 4 lies outside, so no need to find the residue. We find residue for inside point. Okay, we find for the simple pole which lies inside, for that particular point we are going to find the residue. We know for residue for a simple pole is given by this equation, limit z tends to a, z minus a, f of z. So a is 2, limit z tending to 2, z minus 2, f of z is our question. So you can substitute f of z, that is this particular value, 3z plus 1 by z minus 2 into z plus 4. Then this one get cancelled. Then for z you put 2. 2 3s are 6 plus 1. Here 2 plus 4 6. Therefore the answer is 7 by 6. Therefore by Cauchy residue theorem, our answer integral over c f of z dz is 2 pi I into sum of residues 2 pi I into 7 by 6, because only 7 by 6 we take. Residue for 2 is considered because the other value lies outside. Okay, for outside point we are not going to calculate. Okay, z is equal to, from this we get z is minus 4 lies outside C. Outside C. Okay, this lies outside C. Therefore we no need to calculate for outside point, we calculate only for inside point. So only for the, so we consider the residue for the inside point, and it is 7 by 6. So our answer is 7 pi I by 3. So next question, same. Evaluate z square plus 7 by z plus 3 the whole square into z minus 2 dz. C is mod z equal to 1. Find out the poles. Denominator you get it to 0. Here you get z plus 3 is 0. Z equal to minus 3 2 times, because you have square, it has 2 times, therefore it is a double pole. When you come here, z equal to 2 is a single pole. Now when you substitute minus 3 here, modulus of minus 3 is 3, which is greater than 1, so it lies outside. Okay, we'll be finding like this, modulus greater than 1. The next value 2, modulus 2 is 2, that is also greater than 1. So both the value lies outside. Since both the poles lies outside, integral over c f of z dz equal to 0. So only for inside we can apply Cauchy residue theorem. For outside points the answer is 0. Therefore integral value is 0.